Hello guys, what's up? Thank you for the support you have given for my FinFed video. On that note, I thought I can make one more video on some other part of my VLSI industry, that is stand cell layout. Let me cover stand cell layout techniques in this video, and I will try to cover. I'm not sure whether all the things which I'm putting in front of you is correct or not, but I will definitely try to put something which I learned in my experience thing in VLSI industry. Yes, let's get started. Before going that, and you can see here Spiderman is the in a layout. That means what we are working in the VLSI industry, and the layout guys are like Spidermans. Yes, because we used to work with colorful environment, as you can see there. From one building to other building, we used to jump, right? Similarly, we used to get the same experience. I got the same experience. That's why I'm presenting the same thing in front of you guys. Fine, let's get started. These are my contents in my video: introduction, stand cell layout techniques, and conclusion. That's it. Simple. Then getting into the introduction part of it. To standardize the digital cell layouts, normally stand cell layout means mainly it deals with the digital layout part. Unlock will not come that much, and as we all know, like it will be a fixed height things, and in a row we will have the fixed height, and we will place the cells next to each other in abutted manner, so that power continuity will be given in for the each blocks. Yeah, and yes, in block level less metal options will be given for routing, and the main biggest issue will be the area. The area should be minimized. That's the first thing any project manager or project lead will tell you. Fine. Then yes, whatever we do, like RTRC checks we will do, and routing grids we will maintain, all those things will be useful for the planar tool. So planar tool means place and route tool, like Innovus maybe. Those sort of things need some information. Those informations required for the tool understanding will be given by us. That's the main thing. This is just the introduction to the stand cell thing. Yes. Then getting into the techniques which we can use and which we will use normally in VLSI industry is like standardized grid, first part of it, where the grid size will be fixed, and we will follow that standardized grid things throughout my blocks. Yes, and one of the example is given here, like if I say the spacing between my two metals is 1 micron, and the width of my metal is 1 micron, and then the total thing will be a 2 micron thing from here to here. Yes, and yes, this will be obtained, and we will say this as a track, and I will get back to this part later. And just remember that, like minimum design rules will decide my grid size. Yes, remember that thing. And yes, as I said before, whatever we do is for the planar tool. So for the auto router, that is the planar tool, in order to recognize the wires and in order to put the wires for the connections, the metal should be placed on the grid, and there are conditions on this, like if routing congestion is seen, then only these conditions, like if metals are on grid, then only top level router will take the connection, otherwise it can't take those things. Like those conditions will come into picture. So just keep that in mind, like best to keep the metals on grid in both X and Y direction. Yes, and this holds good only for higher metals. Metal 1 will not be considered for this tool. like metal one need not be on grid always. Yes, and yes, only higher metals must be placed on grid. That's cool, right? Yes. Then next, getting into the second techniques, we have direction layer techniques. Before getting into this, and one more question normally people will ask, like why metal orientation is required, like metal 1 should be horizontal, metal 2 will be vertical, then metal 3 will be horizontal, so they like that. There are two reasons for this, as I mentioned here, like to avoid routing dead ends and to minimize parasitic gaps. You'll get so many documents on this in internet. This is not my cup of tea right now, so you can go through this in depth in nets and websites and all. Fine. Getting into the directional layer techniques, let me assume a case where I have metal 1, like these 3 strips are there, and I want to start from here and I want to get into there. In order to do so, I can't use metal 1 for this, so I has to go for higher metals for this. This is one of the simple scenario, but the scenario might be complex when it comes to top level and all. Yes, something like this. Yes, and yes, if we are not following some rules like directional layer techniques and all, we will get into a dead end and it's difficult to come out of it, and we are not sure where we are going now. Yes, and yes, in order to avoid such scenarios, in order to avoid such dead ends, we will follow some rules like metal 1 should be horizontal, metal 2 will be vertical. In this case, we follow like grey colored ones are the metal 2s and metal 1s are blue colored ones, and wherever corrections are required, I will put vias over there. Yes, assuming via concept and all are known to you guys, I'm explaining those things. Vias means mainly used for the corrections between one metal to the other metal, like M1 to M2 via 1 will be used, M2 to M3 via 2 will be used, something like that. Yes, and yes, normally we will follow this metal routing options, and yes, and this metal layer direction layer techniques will not be used full if I'm having a short jumps. If short jumps are there, in that case no need to use one more metal 2 in between. We can directly go from metal 1 then metal 1 again, if we don't have any restrictions in between. If we have some restrictions with M1 something like this, then we should use M2 in between and to should take metal correction from there. Remember that. Yes, and we got faceless man here is asking a question for all of us, and if you are interested you can answer in the comment box and I will get back to the actual answer and what I felt is correct. First question will be like, which other layers or layer apart from metal and poly can be used for routing? Yes, if you know the answer, please comment in the comment section. Yes, and let's move on. And the technique is height will be fixed. As we know, digital cells means height will be fixed and width will be varied. That means variable width option will be given for us, for layout engineers, standard cell layout engineer I'm going to say. Yes, so in that case, if I have some layout designed like this, these things should be placed in tracks only, like one track, so second track, third track, fourth track, something like that, and width will be varied. That means height will be fixed. As I said, all the standard cell layouts should be placed in a single row type of thing. It should not be variable height kind of thing, because continuity won't be provided in that cases. No, that's why. So normally we will follow this thing, and this is one of the example where inverter is designed in a 12 track stand cell. Yes, and as I said before, one track means something, that is here minimum spacing between the highest metal used and the minimum width of that metal. Yes, and height will be integer multiple of that first track or grid. Normally we will say both are correct only. And a important note will be given here, like horizontal and vertical grids need not be same. Yes, and but they must be integer multiples of basic grid. Why it must be a integer multiple, I will take that part in the next slide. And again, faceless man came in and he is asking one more question, that is, are these values fixed like 7, 9 and 12 track in industry? If you know the answer, please comment in the comment section, and let's move on. And getting to the fourth technique, we will have something called multiple of grid width. Width must be multiple of grid. That the criteria we should follow in block level, I mean to say. Yes, if I consider a layout of an inverter, this must be placed in such a way that we can see that endings are on grid, so that whatever comes next, if I place this cell next to other cell, continuity will be provided and those will be properly abutted. Yes, and they should be properly abutted. That's the main issue, main concern mainly, I mean to say. Yes, not the issue, main concern, sorry. Yes, then getting into the layers continuity, we have one of the scenario here where in well spacing, if I have placed many inverters next to each other with n spacing between them as a separation, then so much area will be lost, right? In order to avoid such scenarios, what we will do is we will put a common inverter covering the regions of it, regions of one inverter, second inverter, third inverter, something like that. Why we are doing so? As we know, area is the biggest concern, that's why. Yes, and yes, this is so important in standstill of DRC checks. Whatever we do, whatever we place the layers at the boundaries, they should follow half DRC distance. Why so? If we are not following half DRC thing, if we place two cells next to each other, after placing them abutted next to each other, we will face some issues. So in order to avoid such scenarios, we will follow half minimum distance rules for each and every layer coming at the boundary. Boundary means normally in industry we will follow PI boundary as our boundary layer. Both are there actually. PI boundary object and PI boundary drawing will be there. Normally PI boundary object will be used. In that case, that is taken as a reference and it will come somewhere here, and one first block will be here, second block will be here, and this layer, any layer it can be, it should be placed at minimum distance, that is half of the DRC distance from the PI boundary. Yes, and in order to verify whether what we designed is correct or not, we will follow some techniques. One of the best techniques what we can do is we will design some half DRC structures and we will place around other cells, something like this. If I say 9 track is my design block level cell, we will place other cells like top abut cells, side abut cells around my cell, and we will induce the half DRC conditions. So like I will place metal 1 at half DRC properly from here, and we will, when this top upper cell is placed next to each other, if my metal is not following half DRC from here, then we will get an issue there, because this top upper cell is having proper M1 half DRC spacing, but this cell is not having half DRC spacing from PR boundary. In that case, here we will face some issues. This is a broad scope of discussion. We can take this up thing later as well if it is required. And moving on, as I said, like, yes, keep our internal components properly placed from all four sides. Remember that, keep that in mind. In interview and all, they might ask this question, why it is required and all. Yes, and this is compulsory. This four sides things, if you are not following in the top level thing, you will face in top level lookup, you will face some issues. Keep that in mind. Yes, while integrating it, it will face serious issues and all. Even though in my block level we are not facing any DRC issue, while placing two cells next to each other, we will face some issues if we are not following half DRC rules. Yes, as the name says, as I said before, half DRC means half of the DRC, half of the minimum DRC we need to keep from the PR boundary. That's it. That much simple it is. And again, one more question came up from Faceless Man. He says, why we are not worried about diagonal layers? If you know the answer, please comment and let's move. And double and quadrate cells and its power routing, how it can be done. Let me take the case where we do have double cells and we do have quadrate cells. Remember that. That means whatever the cells we are designing, we will flip that thing along x direction and we will paste something like this, so that bases will be shorted and VDD will be like this. And if we want to short them as well, we will short using power rails like this BSS and VDD. Yes, this is my quad cell, this is my double cells. Yes, and one more question came up. Yes, why can't we work with a single height cells? Why we are moving into double and quad cell? I have a clue for this. If you are an analog layout engineer, you know why it is required. Yes, let's move on. That's the end part of techniques what we will follow in there in stand cell technique, in stand cells layout. And this is one of the tricky question. Normally they will be asked in interviews and all. That is, why cut poly layers are used. Cut poly layers will come into picture in technologies like 1428 and all. That means less than 28 nanometer. In those sort of technologies, we will see some extra layer coming up. That is called as cut poly layer. And why it is required. Consider the case where we have some coloring information, something like green color ones are OD and other color is poly and cut poly. And if we say we placed cut poly along my poly, that means we are making such layouts. Means while fabricating we will get such layers after fabrication. Yes, that means in the conclusion it says it is easier to etch than fabricating a layer. That means if I want to get much better resolution, we need to go for some other techniques, because in order to fabricate the things, as we know, like it's difficult. Overspilling will happen, underfilling will happen, something like that. Those issues will come into picture. So in order to avoid such scenarios in industry, while fabricating, they will go for some techniques called these cut poly layer techniques and all, where if I want to fabricate two different layers, they just place something like cut poly layers in between two polys, and they will say even though these two are not physically separated, after fabrication they will be separated. That means we will etch out the region between these two polys, and we will separate these two polys here. Similarly here as well. Yes, that's the technique. Like we normally go for etching, means we will prefer etching than fabrication. Nice baby, right? Cool. Then getting to the last part of it, conclusion. If I take a overview, top level overview of any IC, this is one of the IC where we can see our logic block coming into. That means normally in any standard cell there will be, in any IC normally standard cell will be used as a logical block in order to drive some buffers or in order to get some logical implementation over there. Those sort of things will be done with the help of these logical blocks. That is, standard cells are required in that cases. Yes. So yes, obviously it is compulsory in any IC. I feel like that. In future, I'm not sure, but right now it is so. So, Dhira, 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 ye Sultana. Yes. So we should be proud of ourselves. Yes. So standard cell layout is that much important in any IC. Yes. And getting to the last part, that is references. This is the only reference that I will prefer and I will suggest for anyone who want to start their career in standard cell layout. And if you have any questions, you can come